Hey everyone, Dave here again. This mini lecture's on scientific notation. We use scientific notation because generally we're going to be dealing with very large or very small numbers, and it would be extremely cumbersome to write out a lot of zeros in numbers. Essentially that's why we're going to use it. Okay, let's get on with it. How do we do this? Well, how do you actually express a number in scientific notation? Well, it consists of two components. One part is called the coefficient. There it is there. And it's a number between 1 and 9.9. And the other number is called the exponent, and it's some power of 10. And the best way to illustrate that is by example. Here's one here. We look at the number 350. We have to write in the coefficient. Well, it will be 3.5. There it is there. And then the exponent. Now we want this number here, to equal this number here, because that's what we're saying is going on. So what have I got to multiply 3.5 by in order to get 350? Well, the answer is 100. And if you recall previously, I said that these exponential numbers here are really representing a 1 followed by whatever the number of zeros is in the exponent. In this case there's 2, so that's actually the number 100 there. So that's how you would write it in scientific notation. Now that's a little cumbersome. There's a quicker way to do this. It's very easy. What you do is you look at the number that you're going to convert and you work out where the decimal place is. In this case the decimal place is there, of course. And then what you do is you just count the number of decimal places that you have to move in order to get a coefficient between 1 and 9.9. So here we go. 1, 2, there we go. Now it's 3.5. So I had to move the decimal place twice, so therefore the coefficient is 2, and now I can write it as 3.5 by 10 to the 2. Alright, this one here, let me get rid of this messy stuff here. This one here is a similar sort of thing. Here's the decimal place. It's actually written there for you this time. We grab the pen and we start here and we go 1, 2, 3, 4. So the exponent is a 4. Now the only other thing you've got to be a little bit careful about is what the sign is in front of the exponent. Here it's not written, but implied here is the sign is a positive 2. In other words, it's 1 followed by a number of zeros. In this case the sign is negative, meaning it's 1 over 1 followed by a number of zeros. In this case it's 4, so it's this number here, which is obviously 10,000. So it's 1/10,000th if you like. So that's indicating the direction that you'd be moving the decimal point. So if you were to convert back, if I was to make this 4.6 here, and I was converting this number back to this original, I'd go 1, 2, 3, 4. So that's where my decimal place ends up. And then to work out the number of zeros, you merely put them in the available slots. There's 1 there, 1 there, and 1 there. And you can see then I've got the same number as before. Alright, there's just another example for you. I'm not going to go through that now. There's some other examples that you can have a look at. The major point here is that you do the exercises. It's the only way you're going to learn how to do it, basically, not listening to me. Whilst I know it might be entertaining, the major thing is that you get stuck into doing the exercises. Okay, now the other thing that I just want to point out to you is that you're going to be using this and other techniques when you're converting units sometimes. So for example, if you recall in a previous mini lecture I was talking about taking prefixes in the SI system. For example, here we have a kilo. Get that pen again. There it is there, which means kilo means 1,000. So you know that when you look at 1 kilometre, it actually is 1,000 metres. And sometimes you might have to write that as 1 by 10 to the 3, which is obviously what it would be in scientific notation. Alright, now I'm just going to walk you through one other example. It's this one here. And this is to get you used to writing things out properly when you're asked a particular question. So for example, here's the question: convert 155 millihertz to kilohertz. How do you do it? Well, of course, you've got to know what your units are here, and your, or I should say, unit prefixes. In this case, this M is milli, and the kilo is 1,000. Right, and milli, of course, is 1 by 10 to the minus 3, or a thousandth. So if we look at that, there's my milli, there's my kilo. So to go from there up to there, that red line, I should say, just to get to the unit value, you would have to, you can see there that you'd have to multiply by 10 to the 3, because 10 to the 3 by 10 to the minus 3 is 1. I've then got to get to kilos. So I've got to multiply by another 10 to the 3 in order to get my kilo value. In other words, just looking at this, I hope you can see that there are 1 million millis in a kilo. After a while, this becomes pretty much second nature for you to work this out. So if there's a million of them, the conversion factor is, rather than using million, let's use scientific notation. The conversion factor is 10 to the 6. Now that we've got our conversion factor, what we've got to do is formulate some sort of expression so that we can multiply our original figure, or divide it, so that we can get the number that we're after. First of all, let's write out what this conversion factor actually means. So we know that it's 10 to the 6, so that's saying that there's 10 to the 6 millihertz in a kilohertz, or alternatively you could say it's 10 to the minus 6 kilohertz in 1 millihertz. Alright, now we've got to write this expression down. So there's two ways we can do this. We could either say that what we're going to do is take our original 155 millihertz and multiply it by 10 to the 6 millihertz per kilohertz, or it's 155 millihertz multiplied by 10 to the minus 6 kilohertz per millihertz. Now one of these is correct and the other one's incorrect. The way I normally figure out which one is the correct one is I simply look at the units and see whether the units that I'm going to end up with in the calculation make sense. So what I'm after, of course, is an answer in kilohertz. If you look at the first one here, can you see that when you look at the units, let me get my pen again. When you look at the units here, I've got millihertz multiplied by millihertz divided by kilohertz. So my units are going to end up being millihertz squared per kilohertz, which is not what I'm after. So I'm actually after this one, obviously. If it's either one or the other and it's not this one, it must be this one. But do the units I get make sense? Well, I've got millihertz here multiplied by kilohertz, but it's divided by millihertz. So the millihertz cancel each other out, and I'm left with kilohertz as my answer, which is what the question was. So this is actually the calculation that I'm going to use. So if we move on here, here it is. In fact, this is the wrong one. You can see you end up with the wrong units here, and here you can see I end up with the correct one. We've got 155 millihertz multiplied by 10 to the minus 6 kilohertz per millihertz. The millihertz cancel out, and I'm left with kilohertz as my answer. What I would do then is go back and ask myself whether the number itself actually makes sense. In this case it does, and anyway, there's your answer. I'm just going to give you one more example. converting 1.6 megalitres to mils. So first of all, just to summarise, we need to work out what the conversion factor is. This is mega and this is mils. So this is mega and this is milli. So this is 10 to the 6. This is 10 to the minus 6. So the conversion factor is 10 to the minus 9. So you can do it in your head after a while. There's my conversion factor. And then from then on you can do the rest, right? So you do exactly the way I've shown you before. You talk about how many mils you've got in a megalitre, and then you multiply it, and then you can get the answer. So in this case, you can pretty much do it in your head. You've got 1.6 megalitres to mils. I've got 10 to the 9 mils in a megalitre. Therefore, how many mils have I got? The answer is 1.6 by 10 to the 9 mils. Again, it's practice. That's what's going to get you success in doing this kind of stuff. Okay, good luck with all of that.